Ethanol. Yeah, so ethanol is a fuel additive used to oxygenate fuel. MTBE used to be used to oxygenate fuel, although it was found to leak in the groundwater supplies and is also not very safe. So MTBE stands for. You know what that stands for? MTBE. MTBE. That stands for. Is it organic or inorganic? Inorganic. That's inorganic. It's a terbutyl ether. So this looks like this. It's actually a methyl group here. Okay, so this is MTBE. This ether compound. Yeah, so that used to be used as an oxygenating agent for fuels, but then it was found, like I said, to leak in the water supplies, and then it was banned from use. And hydrogen is also another fuel source, O2. So based on the delta H of formation, which I've listed here, which fuel produces the most heat? So what do you think? Okay, so let's draw another diagram on the chalkboard. Okay, you've seen this type of diagram before. Okay, so let's plot on this diagram let's see here. Okay, so this is minus 100, minus 200. So this would be in kilojoules per mole. And this is 0. So let's see, let's plot on this graph the delta H of formation of each fuel. So this is going to be CH4 at minus 74.8. Then C2H6 is going to be just under that. C2H6. And then as we continue on, we have C3H8. And then let's see, C4H10. And then C6H14 is right about here. And C8H18 is about here. And then let's see, ethanol is just under that. And MTBE is at minus 315. And hydrogen is way up here. So note that these are the reactants in our combustion reaction. So what are the products? Yeah, so you told me that when the fuel reacts, it reacts with oxygen and produces CO2 and water. So for our products, we should look up the delta H of formation of CO2 and water. So for CO2, the delta H of formation is equal to, so actually for CO2, let's put it over here. So that's equal to minus 393.5. And then for H2O gas, that's equal to minus 285 or 241.
241.
Okay, so let's see, that's the right over here.
So negative 241.
So for example, let's say you're doing the methane combustion reaction. Okay, so the methane reacts with oxygen, so this is also oxygen up here. Methane reacts with oxygen. It's got to go through our, what did we call this before? What was this energy? That's their activation energy. Okay, so note that we have methane that overcomes the activation energy. It reacts with oxygen, and it's going to form water and CO2. Okay. So if we ignore water and the O2, note that this difference in energy between the CH4 and the CO2, that's going to represent the... Yep. Now let's look at stability. Which fuel is more stable, CH4 or C2H6? Why is this more stable?
Because it
Yep. So the lower the energy, the more stable. Okay, so which fuel produces the most heat?
H2.
Yep. So note that H2 is the least stable of all these fuels. This is going to produce the most heat. Which hydrocarbon fuel produces the most heat? Yeah, so CH4 produces the most heat. Okay, so note that if you're starting from a less stable fuel to give us a very stable product, that's going to be producing the most heat. So really what we're showing here is how that Hess's law works. Okay, let's actually go on to the next page because I've summarized these fuels here. So this is the delta H in kilojoules per mole for each fuel. So note that on a per gram basis, methane produces the most energy per gram. And note that really for the most part, all these hydrocarbon fuels produce approximately the same amount of energy per gram. So note that for octane, 44.5, hexane, 44.8, butane, 45.8, and so on. Okay, note that also, I didn't look up these, but anyway, for the most part, all these reactions are favored by enthalpy. Most of them are favored by entropy. Most of them will produce work. Note that one fuel that does not produce work is methane. Okay, so although methane doesn't produce work, luckily it's exothermic, so it will cause an expansion of the gases. Note that H2, which is supposed to be the fuel of the 21st century, our century, it's exothermic. It's not favored by entropy, but note that it does not produce work. Okay, so because of this, note that H2 wouldn't be burned in a combustion engine, but it would be used in a fuel cell. Okay, so we'll talk more about fuel cells in a few weeks when we talk about electrochemistry. Okay, so I'll see you guys later on this afternoon with that.